Okay, now, so you have what? Two substances have giant covalent structure, Nina?
Yes, teacher.
Which two substances have giant covalent structure?
C.
E only, two substances.
Oh, sorry. C and E.
C and E, right? Because this is what? What is C?
C is the diamond.
E is?
Oh, okay.
Right. Okay. Which substance decolorized aqueous bromine? Go back to your
Alkene.
yes, alkene. So which one? I mean,
B.
right. Okay. Which substance is most likely to be a gas at room temperature and pressure?
A.
Balti,
Yes.
what is A, Balti?
It's calcium and carbon. Calcium and carbon.
What is it? What is this? This is 2 plus 2 minus. So what is A? I mean?
What is A? A is a ionic
compound. Right.
compound. Yeah.
What is D?
Alkane.
D is and Z.
Covalent.
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 How do you know this is covalent? Because it's made up of carbon,
And
hydrogen, and chlorine. So
Yeah.
carbon, hydrogen, and chlorine are non-metal,
Oh,
right?
sorry. You're not.
Covalent. These are giant covalent, right? And then these are covalent as well, right? So which substance is most likely to be a gas at room temperature? Please. Which substance is? Okay, which substance is more likely to be a gas at room temperature and pressure? You're talking about
Covalent compound.
B and
D.
B and D. Right. So B and D. Anyone, either B or D. Now, which substance is hydrocarbon?
B.
B.
Why do you choose B?
Because
A
it's
is
only
C
made
double bond,
of
C double bond.
carbon and hydrogen.
Yes. Remember, what is hydrocarbon? A compound.
is
Compound that is made
Organic
up of
compound made
only
of hydrogen and carbon only.
Determine the simplest formula for substance D.
Yes.
C5H5Cl5.
5H.
H5.
1, 2, 3, 4, 5. Yeah.
5.
5.
Right. Okay. And then, so 5, 5, 5. What can you do? The simplest form
CHCl.
HCl. Okay. What do you call simplest formula? Empirical formula. Okay. Look at first page. Look at the first page.
Yes.
Okay. Balkis, read the answer.
Yeah, okay. Sodium chloride is in a regular arrangement, while nitrogen is a free-moving ion. Sodium loses 1 electron, while chlorine gains 1 electron to achieve stability. Therefore, it is strong and requires high energy to break the bonds and high boiling point and melting point. Nitrogen are held in weak van der Waals forces, so it required less energy, so less melting point and less boiling point.
Melissa, read yours. Read yours.
Sodium chloride has a regular arrangement between sodium ion and chloride ion, and is attracted to each other by electrostatic attraction. Nitrogen gas moves freely and nitrogen molecules move freely and are far apart from each other and are held together by weak van der Waals forces. Nitrogen is more volatile than sodium chloride because nitrogen has a lower boiling point due to its weak intermolecular forces. Sodium chloride can conduct electricity while nitrogen cannot because sodium chloride has free moving ions.
Nina, read yours.
Sodium chloride. Ions in sodium chloride are held together by strong electrostatic attraction, and ionic bond is formed between metals and non-metals in a compound. Nitrogen are held together by van der Waals forces, and covalent bond is formed when there is sharing of electron between two or more non-metal atoms. For sodium chloride, it's not that volatile because it has a high melting and boiling point. But nitrogen is very volatile because it has low boiling and melting point. So for sodium chloride conducts electricity as there is free moving ion when it is molten, but nitrogen does not conduct electricity as there is no free moving ion.
You try.
Yeah.
Teacher,
Ada.
teacher,
Yes.
can I correct my last sentence?
Right. Atika, do you try? Atika?
Yes.
Atika, read yours.
Sodium chloride is ionic compound. Ion is held together in ionic lattice, which is held by strong electrostatic force. It means large amount of energy from hence high melting and boiling points. Sodium chloride conduct electricity process moving ions. Nitrogen is a simple covalent molecule. Between them, there is weak van der Waals forces. Hence, small amount of energy to overcomes the low boiling point and get at room temperature. Nitrogen does not conduct electricity because there is no free moving ion.
Okay. Okay, now. So in terms of volatility, you have sodium chloride and nitrogen. This is volatile,
Volatile.
non-volatile. Can whoever that is mute your mic. This is non-volatile. Volatile. You have to mention that. Sodium chloride is non-volatile and volatile. Now, being now you explain sodium chloride, the ion in what?
In a
In
regular arrangement.
Regular arrangement.
Apa? Ionic
Ionic lattice.
ionic lattice. Right. Held in an ionic lattice with strong
Electrostatic attraction.
electrostatic attraction. Right. So which requires
High
amount
energy.
of energy to overcome. Right. Okay. Now here you talk about nitrogen. Now nitrogen is a covalent molecule. Okay. So nitrogen
Wow.
simple covalent molecule. Right. Okay. Do you the is with the molecular forces? Okay, because remember van der Waals forces. If you remember, put it with van der Waals forces between the molecules. So therefore, this is weak, so it requires much less energy. So you don't have to mention about using electron, getting electron battery, whatever that is.
Teacher.
Mic siapa tu?
I can hear you clearly.
No, can you mute whoever mic that is?
I think it's Amin.
Amin.
It's me. Wait, hold on.
Yeah.
Yes.
Yes.
Okay, so first you mentioned, because it says here volatility. So you mentioned sodium chloride is non-volatile. Nitrogen is volatile. So now you explain why. That in nitrogen, in sodium chloride, the ions are held in an ionic lattice with strong electrostatic attraction that requires a lot of energy to overcome. Therefore, high melting and boiling point. But nitrogen is a volatile. Nitrogen is volatile. Okay, and then you mentioned nitrogen molecules are simple covalent molecules. The molecules have weak van der Waals forces, are held together by weak van der Waals forces that requires much less energy, hence low melting point and boiling point. Right? Get it? Because they ask you to compare, describe the structure and bonding in differences in their volatility. Now, electrical conductivity. So, which one conduct electricity?
Sodium
Chloride.
You salah kat mana Nina? Betul kan Nina?
In its
Chloride conduct electricity in
Molten and aqueous.
molten or aqueous.
aqueous. So, sodium chloride conduct electricity in aqueous because of the presence of free
Free moving ion.
ions, right? Well, nitrogen are made up of, nitrogen are simple covalent molecules. There's no ions present in nitrogen. Therefore, they don't conduct electricity. Understand?
Teacher,
Yes.
do we need to describe its structure and bonding?
Yeah.
Or can we just straight away go to the difference in the volume?
You mentioned about sodium chloride is non-volatile. Okay, because sodium chloride, the ions in sodium chloride are held in an ionic lattice. This that you already described the structure. Right, and then you mentioned about electrostatic attraction. You mentioned about the strong electrostatic attraction. What's the consequence of it? It requires large amount of energy, so high boiling and melting point. Right, and then mentioned about nitrogen. When you mention about this is a simple covalent molecule with weak van der Waals forces between them, you are mentioning about structure and bonding again. Understand? Yes?
Yes.
Yes.
Any one of you get 5 marks? I don't think.
I can't tell.
No, because
No.
out apa? Sodium chloride conduct electricity.
Oh yeah, that part, yes.
Mention in molten or aqueous
Aqueous.
presence of free moving ions. Okay? You kena cakap. Kalau you kata sodium chloride conduct electricity saja tak boleh Min. Okay? Now, do your correction. Now, complete the electronic structure of molecule of ammonia. Show only the outer electron. So, nitrogen group 5. So, it needs another 3. So, it shares 1,
3.
2, 3, 4, 5. Right. Nitrogen 1, 2, 3. That's it. Right. And then you do the legend. Here is electrons from nitrogen. And then here is the nitrogen. Okay. Now, next one. Silicon has a giant structure which is similar to the structure of diamond. Okay, do this. Done? Now, name the type of bond which is present between silicon atoms in silicon. What is this?
Giant covalent bond.
The type of bond. Is there a giant covalent bond? Ada tak giant covalent bond? Ke covalent saja? The giant covalent lattice. The bond is covalent. Understand? Balkis?
Okay. Yes.
Now, suggest 2 physical properties of silicon. Use your knowledge of structure and bonding to explain why silicon has these physical properties. The first property, Atika? Are you there?
Physical properties.
Physical properties. When you talk about physical properties, is what? Melting point, boiling point, you know.
Strong.
It's strong. Right. Mana dia dah lari. Okay, it's strong. Why is it strong?
Because it
Okay,
has a strong covalent bond.
yes, they have strong.
Covalent bond.
Silicon are held by strong covalent bond. Or you can mention that they are silicon have giant covalent lattice structure. Okay,
Oh,
they
okay.
have a giant covalent lattice structure. Okay, now second properties.
High melting and boiling point.
High melting boiling point, right? And boiling point. Reason?
High energy is needed to break the bonds.
What bond are you talking about?
Giant covalent, strong covalent bond.
Strong covalent bond. Dia giant covalent lattice, tapi bond dalam faham tak?
Yes, I mean
They have high melting boiling point. Right. Kenapa? Because large amount of
energy.
energy to overcome right. From industrial areas are found to contain small amount of carbon monoxide. How this carbon monoxide is formed? We just
Incomplete combustion of oxygen.
sekali lagi Nina.
Insufficient oxygen.
What? Incomplete combustion of what? Nina, tadi you kata incomplete combustion of oxygen.
Hydrocarbon.
Incomplete combustion. Fossil
fuel.
Remember, okay, because you're talking about industrial area. Industrial area use fossil fuel. So why is it that you have carbon monoxide? Carbon monoxide is whenever you have hydrocarbon, remember incomplete combustion will give you carbon monoxide.
Carbon monoxide.
Why carbon monoxide cannot be inhaled?
Yeah, it is a
respiratory poison.
Yes.
Okay, it's a respiratory poison. Remember, it combine permanently with your hemoglobin. So that reduces the amount of oxygen that is carried by your hemoglobin. Now, that's at room temperature and pressure, whereas silicon fluoride is solid. Okay, now name the type of structure which the following compound have. Carbon dioxide?
Simple covalent structure.
molecules.
Simple
Covalent
covalent
molecule.
Was silicon fluoride?
Giant
Covalent lattice.
Lattice. Now use your knowledge of structure and bonding to explain why carbon dioxide is gas at room temperature and pressure, whereas silicon fluoride is solid. So how do you explain it?
For carbon dioxide has weak van der Waals forces.
Okay, so
Less energy is needed to break the bonds.
van der Waals forces
Between the molecules.
Small amount of
energy needed to overcome
break the point.
So you talk about low melting point and boiling
point.
Right. For silicon dioxide,
It's held together by strong covalent bonds.
dioxide atoms are held by
Strong covalent.
covalent bond. So of an for low, high,
High melting point and boiling point.
melting point, and boiling point. Right. Okay. Do you get marks there?
Yes.
Yes.
Okay.
Teacher,
Yes.
I wrote one of my properties in the silicon peroxide, the question above transparent. Can I do that?
Yeah, but why transparent?
Because there are spaces between the atoms that allows light to pass through.
We call that
What?
tetrahedral
Oh,
because it's tetrahedral. Okay, remember diamond? Why diamond is transparent? Because it has a tetrahedral
structure.
Don't make a mistake because sometimes the student will say it has high melting and boiling point because of it has a tetrahedral structure. No, tetrahedral structure doesn't make it high melting and boiling point. High melting and boiling point because of the strong covalent bond.
Bond.
The tetrahedral make it transparent. Okay, Amin? Okay, now do this. Now, carbon dioxide and silicon peroxide are outside of group 4 element. Okay, both are group 4, but they have different properties, right? What's the
Apa teacher?
I mean,
mute? I mean, yes, thank you. Okay, carbon dioxide and silicon peroxide, both are from group 4, but they have totally different properties.
properties.
What's the formula for carbon dioxide?
CO2.
CO2.
CO2, right? Then melting point of carbon dioxide is negative 56. Silicon peroxide is 1610. Physical state at 25 is gas and silicon peroxide is
Solid.
solid. Right, okay. Conduction of electricity, carbon dioxide is non-conductor, silicon peroxide?
Conductor.
No,
Conduct-
non-conductor.
Semiconductor.
Okay. Semiconductor, when you do your physics, yes, it's a metalloid, it's a semiconductor. As of now, it's non-conductor.
Oh.
The structure, carbon dioxide is
Simple covalent
Simple
molecules.
covalent.
simple covalent, while silicon peroxide is macromolecular. Okay, you notice that Nina kata tadi tau, bila you buat banyak, you notice soalan ni more or less?
Sama.
More or less.
Sama.
So that's the reason why you have to do a lot. Name the type of bond that exists between the atom and silicon peroxide.
Giant covalent.
Again?
Giant covalent lattice.
Okay, this is I think the 4th time I kata. Is there any such thing as giant covalent bond?
Ada.
No.
Just covalent bond.
It's just covalent bond. Okay, covalent bond.
Covalent.
Where do you find this covalent bond? It so happens in silicon dioxide is in a giant covalent lattice structure. But the bond in giant covalent lattice structure is covalent bond. It's not giant covalent.
Covalent bond is
Why
giant
silicon
covalent
dioxide
lattice.
has a very high melting point? Nina?
Is silicon, it has a strong covalent bonds, therefore high energy is needed to overcome the bond.
Yes. Okay, so you talk about strong covalent bond which requires large amount of energy to overcome. Right. Explain in terms of attractive forces within particle why carbon dioxide has a very low melting point, Nina.
Attractive forces.
Shall we see?
Yeah, the carbon dioxide has a very weak van der Waals forces between the molecules.
Wonder walls
Forces between the molecules.
between the molecules. Right. So require
Less energy is needed to overcome the bond.
right. To overcome. Now, explain in terms of particles why carbon dioxide is non-conductor of electricity. I mean,
there are no free moving ions.
No free moving ions, right? So carbon dioxide does not have moving. That's right. Suggest a chemical equation for the reaction between sodium hydroxide and carbon dioxide. Marcus.
Yes, teacher.
Suggest a chemical equation for the reaction between sodium hydroxide and carbon dioxide.
NaH plus CO2 given
Na
NaH plus CO2.
Na plus CO2. Atika?
NaH.
Atika, try.
NaOH
Yes.
Yeah.
plus
Plus.
CO2.
Okay, if you don't know, ask yourself, Atika, what is this? What is this? What is oxide of non-metal? Acidic or basic?
Basic.
Non-metal is
Acidic.
acidic. Right, remember carbon dioxide, acid rain, oxide of nitrogen, sulfur dioxide, acid rain, right? Acid plus alkali dapat apa? Salt and water. So what is the salt?
Sodium carbonate plus H2O.
Right. Okay, balance the equation.
2 to the left side and
So you have two sodium, two oxygen, four oxygen. So what should you do?
2,
You have 3, 4 oxygen. Right, two hydrogen, one carbon, balance. Okay. Now, those of you who didn't know, remember what is sodium hydroxide? Sodium hydroxide is an alkali. Carbon dioxide is oxide of non-metal. You just finished your periodic table. Oxide of non-metal is acid. Acid plus alkali will give you salt and water. Ina, do you get it right?
Yeah.
Okay, hydrazine. Diagram shows the structure of hydrazine molecule. Okay, now, a quick one, 2 minutes. Start. How do you do it? Nitrogen, hydrogen, hydrogen, and hydrogen. Okay, nitrogen group berapa?
5,
5. It requires another
3.
3. 1, 2, 3, 4, 5. Okay. Now, hydrogen requires another 1.
1.
Right. So, hydrogen requires another 1. Nitrogen, 1, 2, 3, 4, 5. Do you get it? Yes? Okay. Everyone got it right? Balkis, betul tak?
Saya punya salah.
Okay. How you make sure that you get it right? You have to be good with your periodic table. Look at your periodic table. Nitrogen group 5, it requires another 3, Balkis. So, kalau it requires another 3, dia akan share 3. Kalau it requires another 2, dia akan share 2. So, do the sharing first. 1, 2, 3. And then 4, 5. Get it? Nitrogen, hydrogen, 1, so they need another 1 for a duplet stability. So 1, 2, 3, 4, 5, 6, 7, 8. Right. So at the end of it, both hydrogen achieve duplet, nitrogen achieve octet stability. Now, nitrosyl chloride is a gas at room temperature. It has a structure shown. Complete the dot and cross diagram to show the arrangement of the outer shell electron of nitrosyl chloride. So you have nitrosyl chloride. And then what do you notice here? NO, nitrogen, oxygen has a double bond. So if it's a double bond, how many? Sharing of 2. Right. 1 here, nitrogen ada berapa? 5. So 1, 2, 4, 5. Right. Now oxygen group?
Group
3. So it requires another 2. 1, 2, 3, 4, 5, 6, 7, 8. Right, chlorine group 7. So therefore, so 1, 1, 2, 3, 4, 5, 6, 7, 8. Right. Now, nitrosyl chloride has a boiling point of negative 6 degrees Celsius. Why nitrosyl chloride has a low boiling point, Nina?
The nitrosyl chloride has a weak van der Waals forces between the molecules. So
Make
in,
a statement first. Make a statement first. Nitrosyl chloride is a simple covalent molecule.
okay.
Start with
Nitrosyl
carbon dioxide is gas at room temperature. Nitrogen is gas at room temperature. You have to make a statement first. Okay, so
okay.
nitrosyl chloride is a simple covalent.
Molecules.
Yes, simple covalent molecules. Okay, then only.
Okay.
Then only you. So what?
Nitrosyl chloride is simple covalent molecules. So it has a weak van der Waals forces between the molecules.
Okay, kalau topik kata a weak intermolecular forces, kalau you tak ingat ni.
Okay.
Which requires
Less energy to overcome the bond.
to right. Okay. Now, tetrafluoromethane and lead-2 fluoride are fluorides of group 4 elements. Some properties of tetrafluoromethane and lead-2 fluoride are shown in the table. Okay, now tetrafluoromethane, the word itself, tetrafluoromethane. Fluoromethane, methane, right? Tetrafluoro, so CF4. Right, lead-2 fluoride is PbF2. So what's the difference between these two fluoride? What is the difference here? PbF2, what kind of compound is this?
Lead chloride.
Fluoride, what kind of compound is this? Marcus,
This is ionic.
ionic. What made you think this is ionic?
Because it has a metal and non-metal.
Yes, because it's metal and non-metal. Good. It's metal and non-metal, therefore it's ionic. But tetrafluoride, tetrafluoro is
Tetrafluoro
tetrafluoro
covalent.
is covalent because
Because
it's
it's
made up of
non-metal.
carbon and fluorine, right? Non-metal. So now melting point -184,855, boiling point. Conduction is conduction is only non-conductor but good conductor. What is the formula of lead-2 fluoride?
PbF2.
PbF2. What type of bonding is present between the atoms in tetrafluoromethane?
Covalent.
Covalent. What type of structure does solid lead-2 fluoride have?
Ionic lattice.
Yes, ionic lattice. Now explain in terms of attractive forces within particle why lead-2 fluoride has much higher melting point than tetrafluoromethane. The answer should be here. Ionic lattice. So you're talking about what? Strong
Strong electrostatic force.
Strong attraction. Strong
attraction
attraction.
which require large amount of
Energy to overcome the
Energy.
bond.
While when you talk about CF4,
It is a simple covalent molecule.
Simple covalent molecules.
simple covalent
So less energy.
with weak
With weak van der Waals force.
Van der Waals.
energy. Right. Get it?
Yeah.
Okay. Do you think you can finish all?
Yes.
Yes.
Would you like to finish all?